In this video, we are going to go over sinusoidal models and applications of sinusoidal equations, so sine and cosine. So in our first problem, it says Sophia is at summer camp. One day she is swinging on a rope tied to a tree branch, going back and forth alternately over land and water. Sebastian starts a stopwatch. At 2 seconds, Sophia is at one end of her swing, which is a distance of negative 23 feet from the riverbank. At a time of 5 seconds, she is on her other end of the swing at 17 feet from the riverbank. Assuming while Sophia is swinging, y varies sinusoidally with time. So we're going to sketch a graph. So something I know is that the maximum height was 17 and my minimum height was negative 23. And so I want to use those to help me find the sinusoidal axes. So I want to find the midpoint between 17 and negative 23. So if I do 17 plus 23, I would get 40 and divide it by 2, and so then my amplitude would be 20. So my sinusoidal axes would be at negative 3. And then they give us 2 points. So they're saying at 2 and at 5. So at 2 seconds, she was at the minimum, negative 23, and at 5 seconds, she was at the maximum of 17. And so since we know this follows a sine-cosine type pattern, I know that if this is the minimum, it'll look something like that, and if this is the maximum, it'll look something like that. And there'll be a point somewhere between 2 and 5 on my midline at negative 3. So what are some of the things I know? My sinusoidal axis is at y equals negative 3. We said my amplitude is 20. All right, let's figure out what the period is. So I know that this would keep going like this, and so I'd have 2 more points. So this is only half the period, and so half my period is 3 seconds. So that means my full period would be 6 seconds. And so we're going to need this to help us in part B when we're going to write the equation. So by looking at this graph, I see a reflected cosine function. So I'm going to start with a negative 20 cosine, and I need to solve for that b value. So I know that my b value is 2 pi divided by b is going to equal my period of 6. Well, since this isn't an easy divide, I am going to put 6 over 1 and then cross multiply. So I'll end up with 6b equals 2 pi. And so I'll end up with b is equal to 2 pi over 6, which would be pi over 3. So my b is going to be pi over 3. And then I'm assuming I'm starting at 2, which I am because that's my minimum. That's at my minimum. I'm going to have x minus 2 plus or in this case minus my sinusoidal axis, which would be 3. They do use t instead of x, so I'm going to replace my x here with t. If you left it as x, though, that's okay. All right, in C, they want us to predict what will happen at 2.8 seconds, 6.3 seconds, and 5 seconds, and then decide if Sophia was over land or water at this time. So based on the model that we see up here, when it was a negative number, that's when she was over land, and when it was a positive number, that's when she was over water. So we could just plug this formula that we came up with in part B into our graphing calculator and substitute in each of the values. The other option is we could take each of these values and just plug them into the equation kind of by hand. We're still going to need our calculator to finish calculating the final answer, but either way is fine. So if I were to calculate these by hand, I would take this 2.8, the 6.3, and the 15. I would plug those each in for t. So I'm still going to use this formula. So when t is 2.8, I know that my y is negative 16.4 feet, and so this would be a land situation. When my t was 6.3, my y was 1.2 feet, and so this would be a water. And then when my t was 15, my y would be negative 13 feet, and so this would be over land. Now in part D, we are going to need our graphing calculator for. So we need to plug the equation into our graphing calculator. And we want to be really careful about how we enter it, because when we type the cosine, it automatically includes a parenthesis. So we want to make sure we add another set of parentheses on the inside. And so it should look something like this when we enter it in our calculator. We also want to make sure we adjust our window based on the graph we kind of drew in part A. So I can see that my Y window would be from negative 23 to 17, and my X window is going to be from 0 to, well, something past 5, probably all the way over to 15, because that's what we calculated in part C. So when we do that, you should see your graph like this. And we're trying to find out when it's less than negative 12. So you want to plug into Y2 that negative 12. And then you're going to find that first interval from here to here of where it's less than negative 12. So you're going to use your intersection tool to find the point here and the point here. And so when you do that, you'll get 0.946 for that first point, for that first X value, and 3.054 for that second value. So that would be that interval of where it first is below or less than negative 12.